Hello, and welcome to Orbit at a Tilt. I'm Adam Tilted, and today we're going to be talking about the Hubble Space Telescope. To help me talk about Hubble, I have a very special guest today. It's my mom. Let me bring her on. Hi, Mom.
Hi, Adam.
How are you?
I'm doing great. How are you
I'm
doing?
good. Thank you so much for being on the show.
You are so welcome.
Can you tell everyone just a little bit about yourself?
Oh, I can sum it up in a few words. I am Adam's mom.
Anything else you want to share?
I have always been a fan of the universe, the skies and the stars and the planets. So I am right there with you, buddy.
Excellent. And I do have to give a lot of credit to my parents because they did make sure that I had access to educational materials, and I ate it up, especially astronomy. So, the Hubble Space Telescope. I'm sure you've heard of it, yeah?
Yeah.
It is probably the most famous telescope in the world. It was named after Sir Edwin Hubble. It launched in April of 1990 on the shuttle Discovery. This telescope has done so much science that it is easily the most prolific scientific instrument ever built. As we know, the Space Shuttle program has been discontinued, which is kind of a bummer because the Hubble Space Telescope was designed to work with the Space Shuttle, and the original plan was to bring it back and put it in a museum after it was finished with its mission. Wouldn't that have been cool? But Hubble has lasted so long and is just getting so much data for scientists that they've extended its mission several times, and of course the Space Shuttle program retired. So we don't have any way to go pick it up and bring it back. So it's going to crash into the atmosphere. 1.3 million observations. Since 1990. The data from those observations has been used in over 15,000 scientific papers, which makes it one of the most productive scientific instruments ever. It is as large as a large school bus, and it weighs about the same as 2 full-grown African elephants. Now, it weighs about 400 pounds more now, I think, than when it launched, because it was designed to be serviced by the Space Shuttle. And it's a good thing because right after it launched, there was a problem. They launched it and realized that there was just a slight flaw in the mirror. Now, the mirror is 7 feet wide. There was a slight error in the shape that was less than 1/50th the thickness of a sheet of paper. That was enough to make the images blurry. What a letdown. We were expecting these crystal clear images like the one that we see here. Now, fortunately, the telescope was designed to work with the shuttle, so they sent a mission up there to fix it, and they were able to repair the optic. During the course of the Space Shuttle missions, the instruments have been switched out for more advanced cameras. They've added some new instruments, which is amazing if you think about that. They go on these spacewalks, flying around the Earth and taking out pieces of the telescope. That's just crazy.
Yeah, that's awesome.
This is one of my favorites, the Eagle Nebula. It's called the Eagle Nebula because it kind of looks like an eagle if you tilt your head to the side, right? It's got the talons here, and this is the body, and I guess, wings, whatever. The Eagle Nebula, this part of the Eagle Nebula, these 2 columns in particular, are called the Pillars of Creation. And those have been very famous targets for the Hubble Space Telescope because this is a region where new stars are being born. And that's very interesting to astronomers because we want to know how that process works so we can understand our own sun better. This is the same nebula but in infrared. You see that the details, we can see a bunch of different kinds of details in this image because infrared is heat. So when there are clouds and dust and things that we saw in the other image, they were blocking what was inside. But with this image, we can see a little bit of the internal structure of this nebula and see how the gases are reacting to the objects around it. That's the Pinwheel Galaxy.
It's awesome.
So Edwin Hubble discovered that there were galaxies beyond the Milky Way, and he also discovered that they were moving away from us. So that's how we know that the universe is expanding. This is another beautiful spiral galaxy. This is, our Milky Way is a spiral galaxy. These galaxies can give us a little hint of what our galaxy may look like. Edwin Hubble discovered that the universe was expanding. The Hubble telescope discovered that the universe is expanding faster and faster and faster. And that kind of blows our minds because based on what we thought we understood about how astrophysics works is that the reason why the universe is expanding is from the force of the Big Bang. Boom! And it pushes everything out. But gravity should eventually, that should slow down and gradually the gravity should pull everything back together. But that's not what's happening. That's where scientists came up with this concept of dark energy, because something that we don't know about is pushing the universe to expand faster and faster and faster. So that's weird. If we were around in a couple billion years, we probably wouldn't be able to see anything in the night sky because we would be so far away from every other object, it would just be dark. Glad I won't be here for that because I miss the stars. This is the Orion Nebula. This is a beautiful nebula. This is one of the objects that I love to image with the remote telescopes from SLU because you can get a lot of really interesting details. I mean, look at those ripples.
They're awesome.
Just the color. Here's another interesting Galactic Collision.
Oh, yeah.
This is my absolute ultra favorite Hubble image. This is the Hubble Ultra Deep Field image. Every speck of light that you see in this image is a galaxy.
Whoa.
Every speck of light is a galaxy. To make this image, they pointed the Hubble telescope at a part of the sky where there was nothing that they could see. About a tenth width of the moon. Just a very small patch of sky. And they just let Hubble soak up light and see what it could find. It found this. By the way, all of these images and movies, all the media is credit NASA, ESA. They are in the public domain and they are available on NASA's website. In fact, NASA has a whole page devoted to Hubble, and Hubble has a Facebook page now. You can follow them on Facebook.
Wow. Wow. Whoa. Wow.
That just blows my mind.
So we really are just dust in the wind.
Yes, exactly. If that doesn't make you feel small, just in that one little patch of sky, that many galaxies. And galaxies we know have billions of stars. And we now know that most stars have some kind of planets.
Yeah.
Wow.
Never ending.
Exactly. The other really cool thing about that image is that it's seeing objects that are 13 billion light years away, which means that it took 13 billion years for the light from all those galaxies to get here. So what we're seeing is what existed 13 billion years ago. That's just a taste of Hubble. I really recommend the website. There's tons of images there. The Hubble has also been used to study the outer planets, such as Uranus, Neptune, Jupiter. It has taken images of black holes. It was instrumental in proving that black holes actually do exist. It hasn't been that long since we've had proof of that. It was kind of just like a science fiction thing, and then all of a sudden it's like, whoa, that's true. There are giant black holes all over the place. Basically at the center of every galaxy. It excites me because it helps get the public excited. And we need more excitement about space exploration. It's important to understand the benefits that we get from space exploration. Thank you, Mom, very much for being on the show today.
You're welcome.
It's so nice to see you.
It's nice to see you, too.
Thanks, everybody, for stopping by. And as always, if you have questions or suggestions for future episodes, leave them in the comments, send me a message, and don't forget to look up.